All right, this is sixth grade, Module 1, Lesson 9. And in this lesson, we're going to be getting into the actual details of the formula for the area of the triangle. So, parents and teachers, that classic formula that we were always, brainwashed into memorizing, but didn't always know why it worked. In this lesson, we figure out why it works. So, let's get started. All right, so clearly they're going to start us off right from the get-go with this idea of there must be something important about the bases and the heights of the triangle, because the very beginning of this lesson, they're really directing our attention to those two things, right? So let's get started. So we're going to... the directions say study the examples and non-examples of bases and heights in a triangle. And so basically they're saying, okay, these things are good examples of bases and heights. And then they're saying, and these things are bad examples of bases and heights. All right. And by the way, when they're talking about bases and heights, they're saying the base is the solid line. And then they're saying the height is that corresponding dashed line. So right here you can see that that's the base and that's the height, and that's how they're indicating it. All right, so as we zoom out and we go, so now we're supposed to find all the statements that are true about these pictures up here. All right, and I've got all these little weird little dots going on. I don't know what the heck's going on over here. I don't know. Who cares? Okay, so let's go. So here we are. It says, number one, any side of a triangle can be a base. Well, let's see. Let's go back up and we'll look, and we're just kind of go. We're going to bounce back and forth between the statements and then the actual triangles because it's kind of inconvenient. Anyway, well, if we look at our examples, we could see the base is here, the base is here, the base is here. Literally, the base, they've given us an example where the base is every single side of the triangle. And, an example where the base could be every single side. So clearly, that first statement, any side of a triangle can be a base. Well, clearly, that is a true statement. So I'm going to put true. All right. Now it says there is only one possible height. So let's go back up and let's take a look. So for all of these examples right up here, so we see here's a base and there's one height right there. But this is also a height. And this is also a height. But they're all the same height, aren't they? And then here's your base, and here's one height, and it happens to be going through the vertex, but does it always have to go through the vertex, that corner? No, because these aren't going through the corner. And here's a base, and here's the height. It's not going through a corner, and you can slide this line. Remember, you can kind of like take this line right here, and you can slide it. I don't know if I'm going to be able to do that. Let's see. Can I grab it? I don't know. Let's see. There. Okay. Let's see if I can move it around. No, it won't let me move it around. But you get the idea. I could take that thing and I can slide it around. Oh, there it is. Woohoo! And I can move it around, right? But it's all the same height. So, to be honest, down here, there's only one possible height. Yeah, well, for the base, for the one base you have, there might be only one possible height, but it could slide around, but it's all the same height. But if you choose a different base, like from the triangle, like if you choose not just this base, and it gives you a height, but maybe if we choose this base, the height is different. So maybe we should say, if we had to guess, there's only one possible height, I'm going to say, let's call that false. Because for each base, there's one height. So let's do number 3. A height is always one of the sides of the triangle. Well, no, we already showed that that's false. For these triangles up here, the height is not a side of a triangle. In fact, it's it's in these cases, it's never, there never is a height where it is the side of a triangle. Now, it is possible for a triangle to have the height be a side of the triangle. In fact, I'll draw a picture of it, but that's false, because it's that word always. But if the triangle looks like this, a nice perfect right triangle, there's your height and there's your base, and the height is indeed the side of the triangle. But that's not always the case, so that is false. A height that corresponds to a base must be drawn at an acute angle. Nope, that's false, because it's got to be a right angle. It's always a right angle, whether the triangle looks like this or not. The base, let's call that the base, and the height itself. So we know the height is going to be right here, but that height always has to be at a right angle, not at a what do they call it? Not at a yikes. There we go. Not, oops, yikes. My goodness. Not at a acute angle. It's got to be a 90-degree angle. Good, so let's keep going. Let's get back down here. Okay, a height that corresponds to a base must be drawn at a right angle. We just did that. We just talked about that. So that answer is true. We know that's true because we just talked about it right here. Once we choose a base, there is only one segment that represents the corresponding height. We know that one. We're going to call that false. Why are we going to call that false? Well, we're going to call that false because once we choose a base, there's only one corresponding segment that could be identified. What did it say? One segment that could be identified as a height. Wrong, because right here we could see once you've identified the base, a lot of segments could be used to equal the height. So that is definitely a false statement. And lastly, a segment representing a height must go through a vertex. Well, we already kind of talked about that. That is a false statement. It doesn't have, the height doesn't have to go through a corner of a triangle. It could, but it doesn't have to. Like if we were to take this height and that's the same height, that's the height, that's the height, that's the height. So of this triangle, each of these green lines represent the height of a triangle, but only one of them actually goes through the vertex right here. So these don't go through the vertex. So that's got to be a false statement. So there we go, answering a bunch of true and false statements. So here, the directions say, for each triangle, label a side that could be used as a base and a segment showing its corresponding height. We're supposed to record those measurements and find the area of the triangle. And in the last row, we're supposed to find a formula. So good, let's do it. So let's go down. And there's our triangles. And there is our table. So here we go. Let's start filling it out. So let's dig into this triangle A. So I see an easy base and an easy height right away. So let's kind of zoom in there. So here's our base. And our base looks like it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our base is 10 units. And our corresponding height right here looks like it's 1, 2, 3, 4, 5, 6, 7. So our corresponding height is 7 units. So our base is 10. Our height is 7. Now I'm just going to keep going and digging into, well, no, let's do it. So what's the area? So the base is 10 units. The height is 7 units. Now we have to figure out what is the area. Well, two ways to find the area of this triangle. There's a variety of ways, but boy, this dotted height already gives us an idea. Because I can see kind of easily that let's make it a little thicker. Let's do that. So I could see right here, that is a rectangle, and I can see that this is a rectangle, and I can see that the blue is half of this rectangle, and this blue is half of that rectangle. So we can find the areas of the two rectangles and cut each of them in half. So let's see, this first rectangle has a base of 2 and a height of 7. So that rectangle here has an area of 14 square units. So the triangle portion has an area of 7 square units. Oh, let's do it in black. So this blue portion is 7 square units, 7U2. I'll do it right here, 7 square units. And then taking a look at this big one over here, the triangle is half of the rectangle. So the base of this rectangle is 1, 2, 3, 4, 5, 6, 7, 8 by 7. So 8 times 7 is 56 units, square units. So this whole thing is 56 square units. Cutting it in half to get the triangle is 28 square units. So we've got 7 square units plus 28 square units. And that gives us 35 square units. So now we can go down to our table and we can give the answer. We can say, we definitely know that the area is 35 square units. All right. Now that's the idea. We're just going to keep digging through each of these triangles, identifying the base and the height of each triangle, and then we're going to find the area using some sort of trick that we have. And that's how we're going to go about doing this. Let's take a look at C. Let's take a look at C, because C is kind of fun. So I see an easy one here, that the base is right here. And so the base is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The base is 10 units. And I see the height right here is 3 units. So what is the area going to be? Well, there's a couple of ways we could do it. We could do negative space. Because I see kind of like an overall rectangle right here. There. I can see the overall, well, yeah, I mean, I could do that. I don't want to, no, let's do something different. Let's say I'm going to take that parallelogram right here, and somehow, I don't know how I'm going to do this, somehow, no, I don't want that whole thing. I don't want the whole thing. Anyway, what I'm going to do, oh geez, my little iPad is having issues here. So I'm going to try, and let's see, 1, 2, 3, 1, 2, 3, 4. So I'm going to draw the same triangle, 1, 2, 3, 4, there. Woo! There we go. So now, you see what I did? I just doubled that triangle to create a parallelogram. So there's our parallelogram right here. So I just doubled this original triangle to create a parallelogram. And we know the formula for the area of the parallelogram. We learned that in previous lessons in this unit, that the base is 10, the height is 3, so 10 times 3 is 30. And if you don't remember how we did that, you can say, well, I can see that I can, let's see, 1, 2, 3, 4. I can take this triangle right here. I can cut it out and move it over here to make a nice, perfect, let's see, get a big, thick pen here, to make a nice, perfect rectangle. And that rectangle has a base of 10, height of 3. So the area is 30 square units. That means the parallelogram has an area of 30 square units, which means the triangle is half of that. This triangle is half of that, so it's 15 square units. So, boy, that's a lot of work that we just did for letter C. So let's get it all zoomed in there. So the base is 10 units. The height was 3 units. The area was 15 square units because we found the area of the parallelogram up here, which was the same thing as the area of the rectangle. And since that was an area of 30 square units, then we just cut it in half. And that gave us the triangle. Woohoo! All right, so I'm going to leave the other ones up to you to do. There's only two others, B and D, and that's fun. But we're starting to get a sense of the formula, aren't we? Because the formula is, you take the base, you take the height, and you do something with it. And I'm going to let you continue thinking about that. And then let's just practice it. So if you don't want, I'm going to give the answer away here. So if you want to still think about this on your own, hit pause on the video and then play with it and then return, and because I'm going to give the answer away right here. So we're supposed to circle the base and then find the area. All right. Find the area of any three. Woohoo! We only have to do 3 of the triangles. Thank you. Open up resources. All right. So good. Let's do A. So I'm going to identify this as our base, which makes this our height. So our formula is base times height divided by 2. So our base is 5, our height is 6, and then we're going to divide by 2. That gives us 30 divided by 2, which is 15 square centimeters. All right, so that's A. That's problem A. Let's take a look at, golly, it doesn't really matter. Let's take a look at problem C. So when I'm looking at problem C over here, I can see that here's my right angle. And so I can see that here's my base and here's my height. So my base is 7, my height is 3. So let's start chugging away. So base area is base times height divided by 2. So that's going to be 7 times 3 divided by 2, which is going to be 21 divided by 2, which is 11.5. And that's centimeters squared. So I'm just going to put units squared because I'm running out of room. So 11.5 square units, and our units are centimeters, square centimeters. So there you go. So I happen to do 2 of them, but you're getting the idea. Basically, find your base. Basically. Okay, find your base. Circle it. Oh, I need to circle that was my base. Find your base. Find the corresponding height. Multiply them, and then divide by 2. There you go. Find your base. Find the corresponding height. Multiply them. Divide by 2. There you go. All right, so triangles are kind of fun. And so there's the summary talking about you could use this formula on the same triangle will work regardless of the base, whether you use this as your base, this is your base, this is your base, because for each base you're going to have a height. And then for this base you're going to have a height. You just take those 2 numbers, your base and your height, multiply them, divide by 2, and that's how you do it. And basically it's because you are taking that triangle, turning it into a parallelogram, and then dividing by 2 to turn it back into a triangle. So here's your nice official formula, 1/2 times the base times height. You'll notice I was writing it a little differently. I was doing base times height divided by 2. But isn't dividing by 2 the same thing as multiplying by 1/2? So yeah, base times height divide by 2, or base times height and then multiply by 1/2. They're the same. They both are going to give you the same result. All right. So sometimes it's easier to think about it as multiplying by 1/2. Sometimes it's easier to think about it as dividing by 2. So we kind of want to be fluent in both of those, don't we? All right. So that's just more of the summary. And let's do some practice. So showing all the drawings in which, select all the drawings in which a corresponding height for a base B is correctly identified. So, for example, let's do it in red. This is the base, this is the height, they form a right angle, so this is correct. This is the base, this is the height, they form a right angle, that's correct. Here's the base, here's the height, that's not a right angle. So that is dead wrong. All right, so here's the base, here's the height. They form a right angle, so that's correct. Here's the base, here's the height. They do not form a right angle, so that's wrong. And then lastly, here's the base, here's the height. They form a right angle, so that is correct. That was a quick one. That wasn't so bad. So here it says for each triangle, a base and its corresponding height are labeled. All right, yay. And it says we're supposed to find the area. How is the area related to the base and its corresponding height? Well, we know that formula. That's the formula. All right, so let's find the area of each triangle and talk about how the base and its, what does it say? How the area is related to the base and its corresponding height. All right, so let's go. Let's find the area of each of these babies. Well, we could see that the base is 4. We could see that the height is 1, 2, 3, 4, 5, 6. So we know if we were to just do 4 times 6, that gives us the area of the rectangle. So the area is base times height. But then we have to divide by 2 because we don't want the rectangle. We want the triangle. So base times, so 4, in this case, it's going to be 4 times 6 divided by 2. And that's going to give us 12 square units. All right, because 4 times 6 is 24. 24 divided by 2 gives us 12. So there's our 12 square. Oh, this blue triangle is 12 square units. All right, just moving over. Let's just skip all the way over to problem C because we don't need to do them all. All right, so the base, what's the base? It's 1, 2, 3, 4, 5, 6. Oh, it's 6 again. And then the height, what's the height? 1, 2, 3, 4. 4 again. So the area is base times height divided by 2, which is 6 times 4 divided by 2, which we already did over there on problem A. So there's our answer, 12 square units. Now, no. That's cool. That's a really cool set of problems. They're kind of showing you to look for patterns. That's really nice. We already talked about how the area is related to the base and its corresponding height. You multiply the base and the height together, you divide by 2, that gives you the area. So yay, we're done. So here's a right triangle. Name a corresponding height for each of the bases. All right, so name a corresponding height for each base. Okay, so if D is your height, your base, then G is your base. If D is your height, a base, then G is your height. There you go. That's pretty straightforward. For side E, if E is your base, then F has to be your height. All right. And then if F is your base, what's the height? It's going to be E right here. And so, wait, did I say E? I think it should have been E. If F is your base, then E is your height. And there you go. And we are chugging away. We're almost done. Find the area of the shaded triangle. Show your reasoning. So how do we find the area of a triangle? You do base times height, right? So what's the base of our triangle? Well, we could choose any side to be the base. I'm going to choose 6 because they give it to us, which means the corresponding height, well, bam, right here, is also 6 because they gave it to us right here. So the base is 6, the height is 6, so the area is base times height divided by 2, 6 times 6 divided by 2, 36 divided by 2 equals 18 square units. Done. Wha bam. All right. And then, oh my goodness, this just keeps going and keeps going and going. Oh, we're almost done. All right, so number 5. Andrew drew a line connecting 2 opposite corners of a parallelogram. All right, sure enough, he did. It's right here. Select all the true statements about the triangles created by the line Andrew drew. So each triangle has two sides that are 3 units long. Each triangle has two sides that are 3 units long. That looks like it's false. All right, so we're going to put an F there. Each triangle has a side that is the same length as the diagonal line. Well, yeah, this triangle has the diagonal. This triangle has so that's a true statement. Yay. True. So each triangle has one side that is 3 units long. That's a true statement because there's the 3 on that triangle and there's the 3 on that triangle, etc. I'm going to let you continue finishing that because that's pretty fun. That's just kind of using logic and stuff, thinking critically about that picture. So here we go. Last problem. Here is an octagon. Goodness gracious. While estimating the area of the octagon, Lynn reasoned that it must be less than 100 square inches. Do you agree? Explain your reasoning. Oh my goodness. So it has to be less is what she's saying. Well, these units here are giving us a clue, aren't they? So if this was a complete square, a nice, perfect square going straight across, straight down, straight across, straight up. So if we had that, we know that the width of that square would be 10 because 3 plus 4 plus 3 is 10. And that the height of that square is 10. 3 plus 4 plus 3 is 10. So the square itself would have an area of 100 square inches. But this octagon has its little corners subtracted off, isn't it? Doesn't it? So we know that those little corners cannot, are taking away from the 100. So Lynn's right. It's got to be less than 100 square inches. Now the question says, find the exact area of the octagon. Boy, this question, parents and teachers, is a really great question because it totally leads us to a nice, efficient way of thinking about the negative space to get this answer. Because how are we going to find the area of the octagon? Well, we know that that whole square is 100. So now that we know that the whole square is 100, we just need to separate and cut out and subtract these 4 little triangles. That's really, really cool. So let's do it. But here's a neat thing. This triangle right here is 3 units by 3 units, isn't it? This triangle right here has a base of 3 and a height of 3. So we can put these 2 triangles together to make a square, a 3 by 3 square, which has an area of 9 square units. And by the way, this triangle here and this triangle here do the same thing and give us another 9 square units. So together, we know that we started off with 100 square units for the entire square, but now we need to subtract 18 because those 18 is those little triangles right here. And so 100 minus 18 gives us, 82. So that's 82 square inches is the octagon. Because we did 100 and we subtracted out the 4 corners, which was 18, and that gave us 82 square units for that green octagon. That's really cool. All right, and that wraps up Unit 1, so 6th grade, Unit 1, Lesson 9, finding the area of triangles, which is base times height, divide by 2, or 1/2 times base times height.